Okay, hi everyone. Okay, so finally we have started. Hi everyone. I hope my voice and everything is okay. Uh, so any sort of error is there? Wait, let me. So please confirm once if everything is okay because I think screen is not visible, right? So let me take. Okay, so fine. So now my voice and everything is okay. Please confirm once. If everything is okay, then we can move ahead, right? So in this session, what I'm supposed to do here is, you know, I will be talking about some other kind of functions. Okay, so I started with the standard, signals, standard functions, standard signals. Okay, so please confirm once my voice and everything is okay, then we can move ahead. Yes, and yes, let me. Okay. So if my voice is okay, then we can proceed ahead, right? So in this session, what I'm supposed to do here is I will be talking about impulse function. Already we have discussed about unit step function है ना, unit step function की बात कर चुके हैं and we will talk about, we have already discussed about rectangular function. तो इस सेशन में हम लोग क्या बात करने वाले हैं? इस सेशन में हम लोग बात करेंगे इम्पल्स फंक्शन के बारे में, राइट? सो इम्पल्स फंक्शन प्लेज एन इम्पॉर्टेंट रोल जब आपको कॉन्टिन्यूस टाइम को डिस्क्रीट टाइम में कन्वर्ट करना पड़ता है. सपोज यू हैव टू कन्वर्ट कॉन्टिन्यूस टाइम सिग्नल टू डिस्क्रीट टाइम सिग्नल, so you need an impulse function as well, right? So आप continuous time signal ले लो and you take one impulse function and you just multiply them, right? So you will get a operation called sampling, right? So you can sample the continuous time signal. Okay, so let me resize myself. Yes. So in this session, what I'm supposed to do here is I will be talking about some standard signal again, right? Standard signals. So the very important, very important function which I'm going to talk about is the continuous impulse. Okay, continuous impulse function. Okay, continuous impulse function. So remember always, continuous function we cannot obtain from the lab, right? We can't generate it. Okay, continuous function को हमने हमेशा हम लोग कैसे obtain करते हैं? Approximation से. Okay, we will take one impulse, we will take one rectangular pulse. Okay, just like we have considered rectangular pulse. Okay, so we will take one rectangular pulse of this nature. You see here, this is one rectangular pulse, right? And the rectangular pulse has the, you can say, width here is from epsilon by 2 to epsilon by 2, and the width is basically epsilon. Okay, so we always approximate impulse function, we cannot generate impulse function in the lab. This you have to keep in mind. Okay, and what is the reason behind that? Now you're going to get quickly, right? So if it is epsilon, so what we have to make sure that this pulse should have the area to be 1, right? So if it is the height is 1 by epsilon, so try to find the area of this. Area is going to be 1 upon epsilon into epsilon. So this is giving the 1 unit area. Okay, so how to get then impulse? So you have to apply the limit here, limit epsilon tending to 0. Okay, limit epsilon tending to 0, 1 by epsilon will give you 1 infinity, right? Okay, this is how you can get the impulse, right? So impulse will be represented using at t equal to 0. We always say that this is 1. Okay, And what is this one represent? Okay, this one represent the area under the impulse function. Okay, so we always take one, you can take rectangular function, you can take a triangular function as well, and then of a finite duration. Okay, of finite duration. And then what you have to do, you have to put the limit. So these are the limiting functions. Okay, so what will be the definition of impulse function? So we always denote impulse function with the help of delta t. Delta t is nothing but at t equal to 0 you will get infinite amplitude, which is not possible. Okay, which is not possible. Is it possible within 0 time you can generate infinite force? No, it is not possible. But we are approximating our we are approximating the rectangular pulse, okay, in to the impulse, you can say, right? And apart from 0, other than 0, it will be 0. So this is the definition for impulse function. And impulse function always defined based on the area concept, right? It is defined as, remember, it is defined as, okay, it is defined as, okay, defined as area, based on area concept, right? It is defined based on area concept, right? Or you can say area under the curve. So what is area under the curve? From minus infinity to infinity, delta of t dt is going to be 1 always. That you have to make sure. Okay, this is one of the property. Yeah, hi Ansika. Okay, so you have to keep this in mind. This is very important concept. How to generate, how to get impulse function. तो impulse function हम लोग कैसे obtain करते हैं? Keep in mind, in the lab it is not possible to obtain impulse. Hi Tanishq. So I think both of you are same or different. Ansika and Tanishq, I think both name are same. Okay, so how to obtain impulse? Keep this in mind. We cannot obtain impulse in the lab. क्यों? क्योंकि 0 टाइम में you cannot produce infinite force. ठीक है, ये आपको माइंड में रखना है हमेशा. ठीक है, तो ये एक डेफिनेशन है. तो कोई पूछता है व्हाट इज कॉन्टिन्यूअस इंपल्स, सो आपको बताना है कि कॉन्टिन्यूअस इंपल्स इज ऑलवेज डिफाइंड बेस्ड ऑन एरिया कॉन्सेप्ट, एंड एरिया अंडर द कर्व शुड बी इक्वल टू व्हाट? एरिया अंडर द कर्व शुड बी इक्वल टू 1, राइट? And you can take as I have taken the pulse here of a finite duration. You can say this is epsilon, and the amplitude should be 1 by epsilon, so that you can have the area 1, right? 1 by epsilon into epsilon is going to give you 1. Okay, this epsilon is a very small quantity, right? A very small duration, you can say. So if you apply the limit, epsilon tending to 0, you will get the impulse. Okay, so I have in some book you will find that delta t is given as integration from minus infinity to infinity, delta of tau d tau equal to 1, right? And 0 for t does not equal to 0. Okay, this is very important definition. In some of the book this kind of definition will be given, and in some of the book they will give at t equal to 0, okay, delta t equal to, at t equal to 0, there is an infinite amplitude. Okay, you can say infinite force, and 0 equal to t does not equal to 0, right? So other than 0, delta t is not defined. Okay, that you have to make sure. So this is just used as the approximation of some standard functions, right? Standard signal. So by approximating you can always get the impulse function, right? So if suppose we have got delta of t, so what is the area of delta of t? The area here is 1. Suppose they have mentioned k times of delta t. So k times of delta t means area is going to be k. So this k does not denote the amplitude. Okay. Yes, Tanish, certainly I will provide the question sheet. Okay. Because we need to cover some concept. Now I think we have done 3-4 lecture on signal system. So I will be sharing some problem sheets. So problem sheets are nothing but my references are I have shared already. One book is Oppenheim. So I think I have shared some of the question also, but I haven't got the positive response. ठीक है, किसी ने आंसर नहीं दिया था. Only there was one girl who answered all the questions. So I want the equal, you can say equal contribution from your side also. Suppose I'm sharing some questions, so you should answer immediately, right? So delta of t equal to what? Delta of t, if somebody is asking what is the area, so how to find the area of anything? Area is going to be evaluated using the integral delta tau d tau, you can say 1. If you apply the area concept here, so integration from minus infinity to infinity, k times delta tau d tau equal to what? You can take k common because k is a constant here, so it is written as delta tau d tau equal to, you know, k only, because this will give you 1. The area under the impulse function is always 1. That you have to keep in mind. Area under the impulse function. So what are the points you have to keep in mind for continuous impulse function? The first is impulse function is one of the approximated function, right? We can't generate in the lab, okay? And impulse function is defined based on area concept. Okay, these are the 2 points which you have to keep in mind. And the third point is, if you want to sample the continuous time signal, okay, you have to multiply continuous time signal, okay. Tanisk, last 2 days I was suffering from fever and I switched off my phone. Otherwise, it's okay. Yeah, you have to respond depending upon your health, right? I'm not okay. So okay, it depends upon you. Please respond every day, right? Whenever I okay. So there are some properties, guys. You know, in many books you will find the mistakes as well. Suppose we have got 3 delta of t, right? Sometimes many local author book claims that this 3 is an amplitude. So this 3 is not an amplitude. Keep this in mind. What is this 3? 3 is area. Okay, the 3 is what? The area. Okay. Now we will talk about some of the properties. So how to represent impulse? Impulse is represented like this. Okay, the arrow will be there and t equal to 0. And if something is written here, suppose I have written k, right? So this k does not represent amplitude at t equal to 0. Okay, it represents the area. The k is what? The area. Okay, and why I have put arrow here? Because this arrow will go to infinite. See, as you put t equal to 0, so this arrow will go to infinity, right? So you can say that impulse at t equal to 0, we are getting infinite force or infinite amplitude, but it is not possible practically. Okay? So let us talk about some of the properties of impulse function. Properties of impulse function, right? So guys, I will also share the you can say I will share the playlist of each subjects. That playlist you have to follow every day. You watch all those sessions, okay? And if you face any difficulty, you can always reach out to me, right? So पहला प्रॉपर्टी क्या हो सकता है impulse function का? Area under the curve minus infinity to infinity delta tau d tau equal to 1. See, you can write delta t dt, okay? Tau is just a dummy variable, okay? You can choose any variable, right? You can choose u, delta u du, okay? You can take x as well, but time is one of the independent variable we always considered in signal and system. ठीक है, कोई भी काम हम लोग करते हैं तो हमेशा टाइम को ही देखकर करते हैं, राइट? वी सॉल्व क्वेश्चंस, वी टेक टाइम इनटू कंसीडरेशन, राइट? सो टाइम को आपको इग्नोर नहीं करना है. टाइम इज ऑलवेज व्हाट? Time is not dependent on us. We are dependent on time, right? Time is always the independent variable. So this is first property. You can always write in words. Area under the impulse. Area under the impulse is what? Equal to 1. The next property is, suppose you are scaling the time here, right? If you are scaling the time, okay, if you are scaling the time means you are just writing delta alpha t, okay, delta alpha of t, okay? So what will be there? It will be 1 upon mod of alpha delta t. So this is the property, you can say time scaling property on impulse. Time scaling, okay? So if delta alpha t is given 1 by alpha mod of alpha, and this alpha you have to take here mod of alpha. So let me take one example here. Suppose they have written delta of 5t. So what will be equivalent here? It will be 1 upon 5 delta t. You can write always like this. Okay. This is very, very important property, time scaling property. Okay. I hope this makes sense. And one more property is there that we call it, this third property, we call it product, or sometimes we call it sampling property. Sampling property. Why we call it product property or sampling property? As I said in the beginning itself, when you multiply, okay, any signal with the impulse function, so you will get sample value of the signal, right? So let me take one example here, then I will explain this property. Suppose we have got any continuous time signal. Okay, you can say this is x of t, right? And we are multiplying this with the impulse. Okay, this is impulse, you can say delta of t, and delta of t exists at t equal to 0. Okay, delta of t exists at t equal to 0. Okay, that you have to make sure. Delta of t exists at t equal to 0 if there is no time shifting. Okay, you can also apply the time shifting. Okay, you can shift the origin. Okay, to the right or to the left. That I will discuss when I will discuss ऑपरेशन ऑन सिग्नल. ठीक है, लेकिन यहाँ पर आपको समझना है कि जो डेल्टा ऑफ टी है, इट इज ओनली डिफाइंड फॉर टी इक्वल टू 0. इट इज नॉट डिफाइंड एनीवेयर अदर देन 0. डेल्टा ऑफ टी इज 0. So if you multiply anything between minus infinity to 0, what will happen? You will get 0 only. Okay, because one signal is 0 completely between minus infinity to 0, and one signal is defined from minus infinity to 0. See how to multiply that. So it is from minus infinity to 0, it is not defined, right? And you can say that at 0 it is a. The value of signal at t equal to 0 is a. Okay, understood? So what we are doing here is we are multiplying. So here you see it is 0 and it is 0, right? So you can say that if you are taking x of t and multiplying with delta of t, so what you will get? You will get always the impulse only. You will get always the impulse. Keep this in mind. This is very important concept, guys. If there is a continuous time signal and you are multiplying what? You are multiplying continuous time signal with the impulse function. So this operation is known as sampling, right? You will get only one sample value. What is that sample value? That sample value is nothing but the signal value at t equal to 0. Okay, the signal value x of t at t equal to 0. Okay, where the impulse function exists. Okay, so you can say that this is x of 0 delta of t. Okay, so x of t delta of t is nothing but what? X of 0 delta of t. So earlier this this delta t has the area. Earlier this delta t has the area 1. Now what is the area of delta t? That is x of 0. And what is x of 0? X of 0 is nothing but a times delta t, because you know that the value of the signal at t equal to 0 is a. X of 0 is what? That is a here. Okay, this is known as sampling operation. So I can take one more question here. Suppose we have got x of t dot delta 2t. What is this equal to, right? So you have to understand that this is a product property. We are just multiplying, continuous time signal with the delta function, or you can say impulse function. So it will be equal to what? It will, you can first take this, you can write delta x of t dot 1 by 2 delta t. Okay, now you can write this as 1 by 2 x of 0 delta t. Why we are writing x of 0 here? Because this delta t exists, okay, exists at t equal to 0 only, right? Okay, I hope this makes sense to everyone. This property you have to keep in mind. This is known as sampling property. The next property we can take here is, suppose, let me take one more question. Suppose somebody is asking what is the value of t times delta t. So can somebody answer? What is the answer for this question? what is the value of t times delta t? Anybody? There are many people who are watching us, right? So can somebody answer what is the value of t times delta t? What is the value of t times delta t? Dekho, what you have to do now, xt is what here? Xt is basically t, right? So whenever you are multiplying xt times delta t, so you have to see the value of the signal at t equal to 0, right? So you can put t equal to 0. What is the value here, Tanis? Tell me here. Or yes, Isika also can answer the question. Other people also. It will be 0, right? Because 0 times delta t, it will be 0. It is very easy question, okay? Suppose somebody is asking cos t times delta t. What is this? What you have to do? Delta t will be there, but now you have to put t equal to 0 in the function, right? So you can say that cos of 0. It is nothing but 1 time delta t. Okay? So it is very easy question. Now there is a property, okay? Now there is a property. We call it shifting property. What we call it? Shifting. This is not the shifting, we call it shifting, right? S-I-F-T-I-N-G, shifting property, or sometimes also we call it area property. Area. Okay, you have to focus the spelling here. S-I-F-T-I-N-G. It is this spelling and this spelling is different. Okay, shifting and shifting is different. Okay, so shifting property we are going to use now. So in shifting property, first property is product property, you can say. First of all, you need to multiply x of t times delta t. Now you are integrating from a to b dt. Okay, so it will be equal to what? It will be equal to what? See, there will be two values. Keep in mind, there are two possibilities. First of all, what is there? What is this? Can somebody tell me? You can write this as a to b x of 0 delta t dt. Now you know that this is now constant. So you can take x of 0 out and a to b delta t dt. Okay. Okay. So I hope this makes sense, right? Because of the product property, you can write x0 delta of t, because you are multiplying what? You are multiplying xt xt dot delta t. Okay. आप क्या कर रहे हो यहाँ पर? xt को कॉन्टिन्यूअस टाइम सिग्नल को डेल्टा टी से मल्टीप्लाई करवा रहे हो, ठीक है? तो अगर आप मल्टीप्लिकेशन करवाते हो सिंगल डेल्टा फंक्शन का कॉन्टिन्यूअस टाइम सिग्नल से, तो सैम्पलिंग होगा. और हाउ मेनी सैंपल यू विल गेट? यू विल गेट वन सैंपल ओनली. अब मान लो अगर ट्रेन ऑफ इम्पल्स से मल्टीप्लाई करवाते हैं, ट्रेन ऑफ इम्पल्स का मतलब है बहुत सारे इम्पल्स रहेंगे एट डिफरेंट टाइम इंस्टेंट, तो आपका पूरा सिग्नल क्या हो जाएगा? सैंपल हो जाएगा. कहने का मतलब है कि मान लो तुम्हारे पास ये साइनोसॉइडल है, राइट? अब इसको अभी आपको सैंपल करना है, तो आपको क्या करना पड़ेगा? आपको यहाँ पर बहुत सारे इम्पल्स डालना पड़ेगा, राइट? एक इम्पल्स आपका लाइक दिस, दीज आर द इम्पल्सेस. ओके, बहुत सारे इम्पल्स, ओके, एंड सो ऑन. ओके, सो जब आप इसको मल्टीप्लाई करोगे तब सैम्पलिंग होगी. तो इसको हम लोग बोलेंगे क्या? ट्रेन ऑफ इम्पल्स. ट्रेन ऑफ इम्पल्स. ट्रेन क्यों बोलते हैं? बिकॉज देयर आर मैनी इम्पल्सेस, so that we can have many samples. Okay, now the thing is here, you see what we have got here. हाँ, अब ये क्या हो सकता है? It can be 1, it can be 0 as well. Okay, there are two possibilities. Okay, so अब देखो यहाँ पर क्या है? a to b delta t dt can be equal to 1 and can be equal to 0 as well. This is very important. Okay, how it is possible? See here, it can be 1, it can be 0 as well. So 1 कब होगा? when delta t will exist inside the limit of a and b. Okay, suppose we have got delta t minus t naught. Okay, so what is the time shifting here? You can say t minus t naught equal to 0. So t equal to what? T naught. मान लो ये टी नॉट से तुम शिफ्ट कर रहे हो डेल्टा टी को, राइट? अभी हमारा डेल्टा टी कहां पर एग्जिस्ट करता है, 0 में। और अगर आप शिफ्ट करते हो डेल्टा टी को, अगर आप डेल्टा टी को शिफ्ट करते हो टी नॉट से, ठीक है, याद रखना ये बहुत इंपॉर्टेंट है। when this delta t resides inside the limit, okay, you can say when 0 is in between a and b, you can say here when this 0 lies between a and b, okay, तब 1 होगा। मान लो तुम्हारा 0 कहां पर है, यहां पर है, और a और b यहां पर है, ठीक है, तब आपका इंटीग्रल क्या हो जाएगा, 0 हो जाएगा। आई होप दिस मेक सेंस टू एवरीवन। This you have to keep in mind. So whenever shifting property question will be asked, so you have to always check the limit, okay, whether that shifting t naught value, okay, here t naught value is what, here in this case t naught value, this t naught value is 0, okay, because delta t exists at t equal to 0, but this delta t exists at t naught because you have shifted this, okay, t minus t naught means t equal to t naught, okay, now your delta t has been shifted to t naught। तो आपको ये चेक करना है कि t naught आपका जो है, this t naught lies between a and b or not। if this t naught lies between a and b, then only the area under the impulse function will be 1। ये बहुत इंपॉर्टेंट है जिसको आपको याद रखना है, ठीक है, ओके। तो अब मैं आपको फिर से बताने वाला हूं, देखो यहां पर मान लो तुम्हारे पास ऐसा आता है कि a to b x of t डॉट डेल्टा t माइनस टी नॉट डी टी, तो इसका क्या आंसर होगा, तो याद रखना, डायरेक्ट याद रखना, इसका आंसर कब क्या होगा, इट कैन बी एक्स टी नॉट, ओके। टी नॉट कहां से मिला, यू हैव टू इक्वेट टी माइनस टी नॉट इक्वल टू 0, टी इक्वल टू व्हाट, टी नॉट, ओके। तो अगर ये टी नॉट पॉजिटिव है मतलब यू आर शिफ्टिंग योर सिग्नल टू राइट हैंड साइड, ठीक है। अभी हम ऑपरेशन में बात करेंगे, आई हैव टू टेक वन सेशन ऑन ऑपरेशंस ऑन सिग्नल्स, हाउ टू स्केल, हाउ टू शिफ्ट, टाइम शिफ्टिंग प्रॉपर्टी क्या है, कैसे हम शिफ्ट करते हैं, हाउ टू मल्टीप्लाई टू सिग्नल्स, हाउ टू ऐड टू सिग्नल्स, ये सभी कॉन्सेप्ट में लोगों को डाउट रहता है। देयर आर मैनी पीपल हु हैव लॉट ऑफ डाउट, तो इसमें हम लोग डिस्कस करेंगे। बस आपको ये समझना है कि ये एक्स टी नॉट हो जाएगा, कब होगा, जब आपका टी नॉट जो है वो किसके बीच में रहेगा, ए एंड बी के बीच में। तो आप इसको लाइन ड्रॉ करके समझ भी सकते हो, ठीक है, नहीं तो ये 0 आएगा, ठीक है। अगर मान लो टी नॉट यहां पर एग्जिस्ट करता है और ए और बी के बीच में एग्जिस्ट नहीं करता है, ठीक है, सीधा सा मतलब है कि इफ टी नॉट या शिफ्टिंग अमाउंट इज नॉट लाइंग बिटवीन द लिमिट ऑफ इंटीग्रेशन, ओके ओके, यहां पर लिख लो, if t naught does not lie between limit of integration, तो आपका आंसर क्या आएगा, 0 आएगा हमेशा, ऑलवेज, राइट। तो शिफ्टिंग प्रॉपर्टी में क्या है, देयर इज टू कॉन्सेप्ट्स, ओके, वन इज द प्रोडक्ट प्रॉपर्टी विच इज यू नो happening inside the integral, okay, and then area property. So I have given you the proof. Let me take some question now. Suppose we have got the question here, okay, 0 to infinity. In fact, I will share some question list from Oppenheim as well, okay, in the group, so you guys can try, right? So this is one kind of question you can expect in the examination. 0 to infinity, t plus cos pi t delta t minus 1 dt, right? Okay, now you know that what is the shifting amount here, you can first find the shifting amount. What is that shifting amount here, so t minus 1 equal to 0, so your impulse exists at 1, okay, your impulse does not exist at t equal to 0. This is very important to understand, okay, because you know that delta of t is nothing but this. Now you want to shift this guy t minus t naught, you want this, okay, so this exists at 1, okay, it does not exist at t equal to 0. So what is the t naught value, t naught value is nothing but 1 this time, right, and this value you have to keep here. Kab, the answer will be what, t plus cos t pi t, sorry, okay, this is basically x of t, right, so answer will be what, x of 1, What is x of 1? X of 1 will be x t. You can take t plus cos pi t, and you can put now t equal to 1, which is 1 plus cos pi, and which is 0. Okay? So you know that what? That shift is, this 1 is lying between 0 to infinity. You can take here the closer look. 1 is here, 0 is here, and the infinity you can say is here, right? So this 1 is lying between 0 and infinite. That is why you are getting some answer, otherwise answer will be 0. See, I can change this question. If I am writing this as, what is the value of minus infinity to 0 t plus cos pi t dt, which is, okay, sorry, here delta t you have to multiply first. So delta t minus 1 dt. What is the value of this integral? Okay, so you have to always check the limit of integration. What is the limit of integration here? Limit of integration is nothing but from minus infinity to 0. And what is the limit here? What is the shifting amount? The shifting amount is nothing but t minus 1 equal to 0, so t equal to 1. So shifting t naught is basically lying here. Okay. So what is the answer here? Can somebody answer this question? What will be the value of this integral? Anybody? What will be the value of this integral? From minus infinity to 0, t plus cos pi t. Tanishq, that answer is 0 only, because t minus t plus cos pi t was there, right? So 1 plus cos pi. What is the value of cos pi? Cos pi is minus 1. Okay. So you have to take care of that. Okay. Here you see, answer will be 0 in this case. Okay, because this shifting amount is not inside the limit of integration, it is lying outside. Okay, so answer for this question will be 0. So this kind of question you can expect. Okay. Okay, one more question I'm giving you now. देखो एक और प्रॉपर्टी है. In fact, property, let me write. The impulse function is even function. Okay, you can say delta of t can be written as delta of minus t. Both are same. Impulse function is kind of even function. Okay, delta of t equal to delta of minus t. If you apply the reflection, okay, if you change t from minus t, so the value will be same always. Okay. Why? What is the reason? Because delta of t is always defined at t equal to 0. Okay, I mean, it is not defined anywhere. Though it is not defined because the value itself is infinite, we call it undefined, right? But you have to approximate, because after all we are studying signal and system. Okay, we are not doing math here, right? So mathematics is different. The signal system needs approximation. Okay, and being an engineer, we must know that where to approximate. Okay, so that we can simplify our life. ये आपको याद रखना है. ठीक है, थोड़ा कॉन्ट्रडिक्शन मैथ और सिग्नल में रहता है, आपको समझ में नहीं आएगा. ठीक है, लेकिन आई विल बी ऑल द टाइम एम्फसाइजिंग कि ये कॉन्ट्रडिक्शन यहाँ पर है. आपको पता है मैथमेटिक्स में इफ एनी फंक्शन इज डिसकंटीन्यूअस, सो वी कांट डिफरेंशिएट इट. बट इन सिग्नल सिस्टम यू विल सी दैट in fact the signal is discontinuous, but we will be able to differentiate it. Okay, because we are working on approximation. We have approximated the signals or functions. Okay, so let me come back to the question now. So suppose we have got suppose based on this question, if I write, suppose somebody is asking what is 4 minus t. So 4 minus t can be written as, you can take minus common here, so it is t minus 4. So you can also write this as t minus 4, nothing. Okay, this minus sign does not make any difference too. Okay, what is the shifting amount here? T minus 4 equal to 0, so t equal to 4. So my signal, my delta of t exists at t equal to 4, and the area is same. Okay, you have to make sure that you have to keep in mind the shifting does not affect area. Okay, time shifting time shifting does not affect area. ओके, टाइम शिफ्टिंग का एरिया में कोई इंपैक्ट नहीं होता है क्योंकि आप टाइम एक्सिस में शिफ्टिंग कर रहे हैं. ओके, you're not changing amplitude. आप एम्पलीट्यूड या मैग्नीट्यूड ऑफ अ फंक्शन या सिग्नल नहीं बदल रहे हो. ठीक है, आप केवल टाइम एक्सिस में मूव कर रहे हो. अगर आप टाइम एक्सिस में मूव करोगे तो आपका एरिया चेंज नहीं होने वाला है. इनफैक्ट आपका योर एनर्जी विल नॉट चेंज, योर पावर विल नॉट चेंज, राइट. ये आपको याद रखना है. ओके, लेकिन टाइम स्केलिंग का इंपैक्ट है. अगर आप टाइम को स्केल करते हैं तो वो एरिया एनर्जी सब में इंपैक्ट करेगा. लेकिन आपका जो you have to keep in mind, if you are shifting something, so time period is not going to change. If you are shifting signal, then you can say area is not going to change. Okay, power will not change, energy will not change, right. So ये सारी चीजें जो unchanged रहती हैं, remain constant. The time shifting does not affect area, it also does not affect energy, it also does not affect power. टाइम पीरियड में भी कोई चेंजेस नहीं आते हैं. ठीक है, ये याद रखना अगर सिग्नल पीरियोडिक है तो ये छोटी छोटी बातें हैं जो आपको याद रखनी चाहिए. तो एक क्वेश्चन हम लेते हैं अगेन बेस्ड ऑन टाइम शिफ्टिंग प्रॉपर्टी, राइट. SIF. ओके, SIF. सो देखो यहाँ पर क्वेश्चन है कि मान लो तुम्हारे पास क्वेश्चन है 0 to infinity e raised to power t minus 3 delta of dt minus 9 dt. So you guys see here, now you have to first of all take care of this. Okay, this is delta of dt minus 9. So this time they have given what they have here, shifting they have done as well as they have time scaling. In this case time scaling is done and time shifting is also done, right. दोनों चीजें यहां पर हुई हैं. टाइम स्केलिंग इज देयर एंड टाइम शिफ्टिंग इज देयर. So first of all you need to apply, you can take 3 common from there, right. So delta of 3t plus minus 9, so you can take 3 common, it will be 3 minus 3. Okay, now you can apply the time shifting property, time scaling properties. 1 by 3 will be coming out, this will be t minus 3. Okay, now you can find the shifting value will be what, 3 in this case. Okay, so this integral will become, ये इंटीग्रल क्या हो जाएगा, 0 to infinity e raised to power t minus 3. okay, 1 by 3 delta t minus 3 dt. जब भी टाइम स्केलिंग एज वेल एज टाइम शिफ्टिंग दिया है, हाँ ठीक है, टाइम स्केलिंग एंड टाइम शिफ्टिंग बोथ आर गिवन, सो यू कैन फर्स्ट ऑफ ऑल understand this. Okay, otherwise your answer will become what, get affected. So your area gets divided by 1 by alpha. Okay, if time scaling is there, so your area gets divided by alpha. Okay, mod of alpha. Yes. So you see guys, this is very important. Now the shifting equal to 3 here, so this is xt this time, right. So you can take here x of t, that is 1 by 3. Okay, so you put t equal to 3 in this case, so e raised to power t minus 3 by 3 and t equal to 3. What is the value here, t 3 minus 3, that is 1. So answer will be 1 by 3 only, because t, if you put 3, right, so 3 minus t matlab t minus 3, 3 minus 3 means 1, 0, right. So anything to the power 0 is always 1. So answer will be what, answer will be 1 by 3. I hope this makes sense to everyone. Yeah, that you have to keep in mind. Let me take one more question to understand. Suppose they have asked question of this kind, minus infinity to infinity x of 2 minus t delta 4 minus t dt. Okay, so in this case you see here you can find the shifting. Okay, as we know that delta of t, the impulse function is always what, delta of t is always impulse, even function. Okay, delta of t is always impulse, even. Remember, impulse function is always even function. Okay, so you can find from here t equal to 4. You will get the shifting here is what? Shifting is t naught. So you can put here. Okay, as you know that 4 lies. You see, this is 4, and from minus infinity to infinity, right? The integral limit is what? From minus infinite to infinite. Okay, I hope this makes sense. So here in this case, what will happen? 2 minus 4, it will be answer. So x of minus 2. This is the answer for this question. How many of you understood this? This is very important concept, guys. Okay. So always check what is the question here. Always check the limit of integration and the shift. A shift lies within the limit of integration. So answer will be not 0. Okay, answer will not be 0. Suppose it does not lie within the limit of integration, then you have to directly you blindly write it 0. Okay, so I will give you some question here that you can answer. Suppose we have got and it can be 0 as well. Okay, depending upon the shift, right? It is not necessarily always, right? But if it is out of, then always it will be 0. But you know, because of some, like we have seen t plus cos pi t, right? So we put t equal to 1. So 1 plus cos pi coming out to be 0. Okay, so first of all, you have to ensure that the shift lies between the limit of integration. If it does not lie between the limit of integration, then always you don't have to do anything. You can directly answer it, right? Suppose they are asking question of this kind. What is the integration of t times delta t? So as we know that this 0 lies between minus infinity to infinity. Yes, that is for sure. Okay, you can just write here, this is 0 minus infinity to infinity. Yeah, perfect. First we are able to ensure here, right? Then what you can do, delta t exists at t equal to 0, right? So you put 0 here. So this answer will be 0. Okay, because function itself is becoming 0, right? X of t is 0 at t equal to 0. Okay, your integral will be 0. So this kind of question you have to keep in mind. So we have discussed till now. Now the question will be based on doublet. Okay, I will teach doublet. Okay, what is the meaning of doublet and all as we proceed ahead, right? So question will be based on doublet. Okay, doublet will be what? The differentiation of impulse function. If you find the derivative of impulse, then you can get the doublet. So we have discussed some till now the unit step function. Okay, unit step function. We have discussed the rectangular function. We have discussed the impulse function. Okay, and we have seen the properties as well. So before I introduce different kind of standard signal again, right, I would like to talk about the operations on signal. That is very, very important, guys. Okay, the operations on signal is very, very important, that we will do in the next session, in fact separate session. So just I will list down operations on signals, right? Operations on signal. And guys, this is very important in entire signal and system. If you know operations on signals, so where these operations is going to are going to help you, you can solve question very smartly, right? And just by observation you can sometimes answer the question, right? So you have to attend that session, the lecture number 5. Okay, so operations will be, first will be, you can say time shifting. Okay, time shifting operations. Second will be time scaling. Okay, the special case in case of time scaling will be time reversal, right? Time reversal. Okay, Also we will combine them, right? So we will be having, you can say, x at plus minus b kind of thing, right, where time shifting and time scaling both are present. Okay, so this kind of situation also might occur. So first of all, what we have to do, first we have to scale it or we have to shift it. Okay, there will be conflict. So I will tell you, पहले आपको क्या करना है, पहले शिफ्ट करना है कि पहले टाइम स्केलिंग करना है, ठीक है। तो एग्जाम में आ सकता है स्केलिंग या, दैट्स व्हाट आई एम सेइंग, कॉम्बिनेशन ऑफ शिफ्टिंग एंड स्केलिंग, है ना। तो इसके बारे में हम लोग डिस्कस करेंगे। और मेजरली हमें सीखना है हाउ टू ऐड टू सिग्नल्स, ये कोई नहीं बताता, ठीक है। हाउ टू ऐड टू सिग्नल्स, ओके, हाउ टू ऐड टू सिग्नल्स, यू कैन से मल्टीप्लाई कैसे करते हैं, ठीक है, क्योंकि दीज आर द बेसिक ऑपरेशन, वी डोंट हैव डिवाइड इट। Yes, doublet I will discuss. Yes, doublet is very important. Okay, doublet is very important. The derivative of impulse, ठीक है, उसके बारे में हम लोग डिस्कस करेंगे certainly. डबलेट हमें बताना है, डबलेट ही इंपॉर्टेंट है उस, ओके। तो मैंने आपको सारा बता दिया है, रेक्टेंगुलर पल्स बता दिया, यूनिट स्टेप फंक्शन बता दिया, बस आपको डेफिनेशन याद रखना है। यू हैव टू रिमेंबर द डेफिनेशन, ओके। इफ यू डू नॉट रिमेंबर द डेफिनेशन देन लाइफ इज ओवर, ओके। एंड नेक्स्ट काइंड ऑफ जो आता है आपका, जैसे मैंने यूनिट के बारे में बताया, यूनिट स्टेप, ओके। सो दीज आर दी ऑपरेशन वी विल डिस्कस गाइस, ठीक है, ये सारे ऑपरेशन हम लोग डिस्कस करेंगे। एंड इनका क्या इफेक्ट है फेज में, जैसे आप टाइम शिफ्टिंग की बात कर रहे हो, तो फ्रीक्वेंसी डोमेन में फेज चेंज इसको बोलते हैं। टाइम शिफ्टिंग का मतलब होता है फेज चेंज इन द फ्रीक्वेंसी डोमेन। ये स्टेटमेंट यू हैव टू ऑलवेज कैरी इन योर माइंड, राइट। This statement you have to take care, if there is a time shifting in the time domain, so there will be phase change in the frequency domain. तो कैसे होगा, e raised to power के phase में, right, e raised to power I theta, theta is the phase, right. So we will see when we will discuss, we will go from one domain to another domain using some tool like Fourier transform or a Fourier series, ठीक है। तो ये याद रखना है। एंड देन हाउ टू ऐड टू सिग्नल्स, ये बहुत इंपॉर्टेंट है, ठीक है। अब जैसे मैंने मान लो बोला कि हमारे वी हैव गॉट वन दिस काइंड ऑफ सिग्नल, रैम्प इज देयर एंड वी हैव गॉट, you can see some constant here, ramp plus constant. So what will happen here, ramp and constant, okay, so that we will see. तो अभी हम लोग थोड़ा सा देख लेते हैं रैम्प सिग्नल क्या होता है, रैम्प फंक्शन। So ramp function is basically nothing but we denote by r of t, okay, and what is the definition here, r of t is defined for t greater than 0, okay, that you have to make sure, okay. R of t is what, t, this is defined for positive time t greater than 0, ठीक है। I think you can find the relation with u of t as well, because u of t was defined for positive time t greater than 0, not t equal to 0, right. So this is, and this will be 0 for t less than 0, that you have to make sure, okay. So r of t is nothing but ramp function. How do we, how to show this, okay, how to represent this, so keep this in mind. R of t is always shown like this, okay. So this is t here, and you can say there is a 45 angle, right. So this is basically the t, okay. I hope this makes sense. So now we can also represent, we can also write r of t as tut, right. In terms of unit step function, we can write r of t equal to t times ut. Why we are multiplying ut? Because you know that if you take t, simply you take t here, suppose we have got x t equal to t, right. So what is x t equal to t? T will be like this, okay. So this is y equal to what? Y equal to mx, right. The slope is 1 and t, this axis takes time here, and this xt is what, the function y, okay. Y equal to mx. But now if you multiply this with ut, okay, so you're just multiplying this and this. You know that from minus infinity to 0, u of t is 0, yes. from minus infinity to 0, u of t is 0, completely 0. So if you multiply something with 0, okay, it becomes 0 only, it is non-zero here. So this part, the part which is existing on this quadrant, you can say, will be absent. What will be resultant then? You can say this will be this, right? And this is r of t. So we can say that r of t is nothing but, in terms of unit step function, which is t times ut. Okay, and इसका definition याद रखना, which is defined for t greater than 0 and 0 for t less than 0. ठीक है? So wherever t ut is written, you can always write rt. Okay, wherever, suppose this kind of situation is there, t minus t naught, ut minus t naught. What is the meaning of this? You can write this as rt minus t naught. Okay, rt minus t naught. Yes. Okay, so you can always multiply, you know how to multiply signals. Okay, just like if I give you some numbers, so what are the things you can do with the numbers? You can add numbers, you can subtract numbers, you can divide numbers, right? If I give you two signals, so what are the things you can do? You can shift signal, you know, you can multiply two signals, you can add two signals, you know, you can do time scaling on the signal. Okay, so these are the operations which you can do always, right? That is the reason these kind of operations are given. Okay, okay, why we are doing these kind of operations? You know that you might have seen the cassettes, right? When we want to listen some music, okay, when we want to listen some music and we don't like that music, what we will do? Yes, we don't go for division. Yes, this is possible with the number, right? So why do we want to suppose we don't like the music, right? So हम क्या करेंगे? We will put at some, we will increase the speed so that we can listen it quickly, right? In fact, we watch the YouTube videos, okay? We always increase the speeds. What we do? We are just scaling the time, okay? Suppose you are doing some work in 9 hours, okay? And I ask you to do that work in 5 hours or 2 hours, right? So what we are doing here is we are doing the time scaling. Okay? Suppose every day you might have seen, I always tell that I'm going to start my session by this time, but I always get delayed, okay, because of some technical issues, right? So what we are doing, we are shifting the time. So what we are doing in our real life, we are going to mathematically model them. ठीक है, तो ये जानना बहुत जरूरी है. तो आप कैसेट्स, जैसे आप पूरा सॉन्ग सुन लिए, पहले ऐसा नहीं था कि डायरेक्टली यू कैन कम बैक. ओके, you have to press the button so that you can reverse entire reel. Okay, then you will be able to listen again. Abhi kya hota hai, directly you are able to, you know, drag it and start listening from the beginning. Okay, so these things were very important those days. Abhi bhi yahi sab hota hai. So I hope this makes sense, guys. We will meet in the next session and we will learn the operations on signal and systems, right? We'll learn how to add, how to multiply, how to shift, how to you know, scale the signal, how to scale time scaling, how to scale okay, so these are very important. Yeah, it was amazing. Yes, Tanis. Okay, so we have to relate with the applications. तो आपको हमेशा याद भी रहेगा, ठीक है? नहीं तो आप क्या करोगे, आप रटोगे, ठीक है? अब आपको प्रॉब्लम सॉल्व करना है, तो मैंने आपको रेफरेंस बताया है. यू हैव टू सॉल्व क्वेश्चन फ्रॉम ओपेनहाइम, राइट, एंड तरुण कुमार. Tarun Kumar book I have shared as well in the group, right? So you guys can try all the examples and then all the exercise problems. मतलब relevant problem you can try. I will share what problem you have to try, right? तो आप पूरा सॉल्व कर लो, आपको सारा आने लगेगा, ठीक है? फिर आप टेस्ट सीरीज दोगे, है ना? I will share some questions as well, separate questions. So this is what the life is going to be, right? So if I share any question, you have to you know, respond quickly, right? चलो ठीक है, we'll meet in the next session. Thank you so much guys. I hope you might have enjoyed some of the basic thing. अभी तो बहुत ही basic चल रहा है. Next session you will enjoy. I will teach DFT as well properly. DFT question is always expected. फोरियर सीरीज जहां लोग मेजरली प्रॉब्लम फेस करते हैं, एंड आई वांट योर फोबिया टू रिमूव। थैंक यू।